Thank you very much for being my guinea pigs for today. It's always fun to be the first of the PyData London session. So as mentioned, my name is Anders. I am Norwegian. I live in Copenhagen and have lived lots of different places. I have a background in Japanese business, actually, so I've had a lot of hats. But currently, I am, as mentioned, the head of the Python enablement team at Nordea Asset Management. So my job is to make sure that we have all the Python tools we need, build up Python infrastructure, do courses, trainings, workshops, sort of be internal consultant for all the teams at Nordea Asset Management. So as you can imagine, a lot of quants, a lot of trading. I'm sure all you Londoners know all about that. This is the Git repo that we will be working with today. So I'll give everyone a second to clone it if you want to follow along, of course. That is, of course, optional. I'm a bit curious before we start. So I assume everyone here is working with SQL, or else I assume you wouldn't be here. But what kind of database are we working with? Can I see a hand for Postgres? OK. MS SQL? Oracle? Poor souls. Did I forget anything? What's in the other category here? All right, excellent. So we got like the three main ones we got covered here. So the great thing is that SQLAlchemy works with all of these. And it lets you sort of write independently of your database to some extent. So if we jump over to the intro over here. So SQLAlchemy is actually a very, very old project in Python terms. I tried to do some digging, but the history of it has sort of been moved from Garrett to GitHub and a bit back and forth. But it's been around for a very long time. It started as a way of layering on top of these other Python database tools that we had. But before we get into that, the reason that we use SQLAlchemy is compared to many other tools that other languages use, or also gets in Python, SQLAlchemy doesn't try to hide away the SQL. So it is a SQL toolkit. It's not a SQL abstraction language. It's not a DSL. It does support the object relational mapper, which lets you do some nice things in hiding away some of the complexity. But again, it doesn't try to hide away the SQL. And you can always dive down into the SQL parts, because one of the big complaints about ORMs is that they are a leaky abstraction, that they mismatch sort of what you're trying to do in your code and what's actually happening in the database, and that leads to a lot of problems down the line. So to sort of support this setup, SQLAlchemy has two main parts. I briefly mentioned them, but we have the core and we have the ORM. And we're going to dive into what those two things are. But first, a bit of history. So PEP 249 was introduced in 2001. There's actually two PEPs at the same time. One was older than the other, but they're both registered at the same date. And that basically specified how do we talk to database libraries from Python. It standardized Python API to do that, and that let all the various providers write a database connector that could be used to do the same thing. So if we take an example that I actually built into Python, so SQLite, as you are probably using every day because it's actually the biggest, most popular database in the world. It's a single file embedded database. So you can import SQLite in Python. It's right there, which is great for a lot of use cases. So we pass it a file name, and then we can use the DBAPI. So usually the pattern looks like this. You have a with something.connect to the connection string. This makes sure that at the end of this block, we close the connection and clean up any lingering connections to the database. And then we can execute some string, which is then sent to the database, parse the SQL, and then you get the result back. Yes? Of course. One more. So if you run this, nothing really happened, right? It feels like it. But if I look in my file system over here and hit the refresh button, I now have this local.db. Again, this is a SQLite specific thing because it's a file database. It creates that database. So I executed this create table, and now I can reconnect to it, and then I can do an insert, and then I can do select. And if I look at this result, I got this list of tuples back. One in text, which was the one that I inserted. So you see already here a few things that the DBAPI is doing for us. It has this insertion syntax to avoid SQL injection. It also parameterizes the types in the sense that you get something binary back from the database. The DBAPI spec takes that and turns it into a Python type. So if I do type of this, you can see I'm getting a tuple. So it's a list of tuples with Python types. So already there, there's a bunch of magic happening, right? But this probably doesn't look great to work with. So why is that? Well, we're dealing with raw strings. As programmers, as Pythonistas, manipulating strings is not why we're into writing Python, right? Also, if I was to take this toy example and switch over to my SQL Server database, I would have to install a completely different library, rewrite all the text, and actually change the code because I have to use the SQLite connection. So if it was CX Oracle for Oracle databases or PyWC for SQL, I would actually have to change my code. And I'm actually not using any of the power of Python. Again, it's all string manipulation, right? So that doesn't feel very Pythonic. So let's try to do the same thing, but this time with SQLAlchemy. I personally like to import SQLAlchemy as SA, sort of like the PyData vibe of two-letter abbreviations, mainly because, yeah, you do use the SQLAlchemy core stuff a lot. That is a personal preference, and it's, of course, up to you. So the first thing we need to talk about is the various objects that SQLAlchemy provides. So the first one we need to know about is the metadata. So the metadata keeps track of all the different tables that SQLAlchemy is in charge of. So it's a sort of a global register for SQLAlchemy to work with, and where it does all this lookups when you're doing joins and stuff like that. It also is quite handy in the sense that it knows the order in which things need to be created. So if you have dependencies between your tables, the metadata registry knows how to figure that out if you need to create a table or drop a table. So of course now we need a table. That is of course the fundamental unit of working with SQL. So we have a table object here. Notice I gave it the name, and then I also pass it the meta object here, and that's to register it into the metadata. And then I have this column construct here, which basically is how SQLAlchemy keeps track of the types of the various columns. So I declare a column named column1 of type integer, and a column named col2 of type string. Of course, this is the very simple basic types, but just matching the previous example. So now we have a table. The third part that we need is the engine. So this is sort of the active parts. This is the part that actually talks to the database and translates SQLAlchemy things into SQL in the database. So the fundamental construct is the create engine. That gives you an engine object from a connection string. So one caveat here, we are in the transition period in SQLAlchemy. Again, it's a very very old project. 2.0 is right around the corner. So to smooth the transition, what they've done is let you set this future equals true flag that lets you opt into SQLAlchemy 2.0 behavior. So if you pass this future equals true, you're basically working in 2.0. When that rollover happens, then you'll be prepared. You're not going to have any surprises. It's also much nicer to work in 2.0. It's much more consistent. It's much clearer what's going on and doesn't have as many warts as the old one, which is, of course, what happens when you go to a major version bump. So we create our engine, and now I'm actually ready to do something. So let's write some SQL. So now I'm writing the same SQL query as before, but now I'm using Python objects instead. So I do a select on the test table, and that creates, again, a Python object, and they overwrite the wrapper. So I get this selectable object, but if I print it, it actually generates the SQL, shows me what SQL is going to be run. So it gives you a lot of introspection in terms of what's going to happen. SQLAlchemy is not going to try to surprise you by doing something else than what it's promised to do. It also overrides a bunch of operators. So for example, I can do this column. Notice I have the .c to access the columns. So it's actually called columns, but because we use it a lot, you can also use .c. Column1 equals test. So that gives me this binary expression object. So that note means that SQLAlchemy can actually translate that into some SQL. So this would be the equivalent SQL of what I just wrote. So adding a where clause is actually fairly simple. I can tag on in fluent programming style .where, and then just write what looks like regular Python. This equals that. And that will generate a select from test where, as you would expect. To run it, we do a connection, just as like we did in the DBAPI style. And then we execute the SQL. And then we say .all means get all the results. So it looks the same, right, visually, but it's actually a bit of an upgraded version because this is no longer tuple, it's a SQLAlchemy engine row. So this row object, it has, for example, access. So I can do column1. In the previous one, it was tuples, I had to do indexing, which isn't very pleasant. It means I can convert it directly to a dictionary, which is very useful if you're trying to pass things through, for example, Pydantic or in your API. So notice here that I use .all. So .all is sort of a go do this. Everything we've been doing until now is lazy until I hit that .all. So you can say .all, get all of them, get one, gets one result, but also raise an exception if there's only one. So it also gets some, if you're doing, aware to look up a customer ID, you expect one result. If there is none, raise an exception. One or none, same with, but it's okay if there's none. First, the same as saying, limit one or a top one for you SQL Server people. Then you can also do things like streaming results. So we're not going to talk about that today, but know that that is an option depending on your database driver. So the different libraries for talking to databases have different options in terms of talking to the database. So for example, if you're working in Postgres, it's very nice to have server-side cursors. You can send your 10 million row results, keep it in memory in the database, and then ask for chunks of it at a time. SQLAlchemy supports that fully through a streaming. So behind the scenes, yes?
Do I get updated data, or do I just get a stream of the data that was there when I started the request?
Yeah, so that's the concept of the cursor, right? So you create a cursor, you send the SQL to the database, that cursor then contains all the data on the database side, and then you're fetching sort of whatever is in that cursor until it's exhausted.
Yeah, okay, so I don't get the new data, if the
No. There are some things where you can actually sort of have a streaming live update, but that wouldn't be a server-side cursor. So, and again, these aren't SQLAlchemy features per se, they're just supporting features that are in modern databases. So if your modern database supports it, and the Python database driver supports it, then SQLAlchemy likely also supports it. So what did actually happen behind the scenes here? So it generated the correct SQL for our database. So SQLAlchemy is database aware. So for example, if you are in SQL Server land, a limit would be called top, right? SQLAlchemy knows that. It will automatically convert a limit to a top. If there are any types or casting or anything like that, it knows how to convert between most things. There are some things that are database very specific. So SQLAlchemy does support it, but in most cases, it will do a conversion automatically, depending on the connection string. It wraps the result of the query in this row object, which gives a nice access to each row. And behind the scenes, which we didn't see, is that SQLAlchemy has a pool of connections by default. So that means it doesn't check out, it doesn't create a new connection every time you make a call. It has a pool of warm live connections that it then rotates between. So that means that you can sort of have lots and lots of queries going and not open hundreds of connections because you can reuse the connections in the connection pool. So these are some of the things that SQLAlchemy is doing for you behind the scenes that you don't get out of the box in others. So that was sort of a very brief overview of SQLAlchemy and why we like it. And now we're going to dive into the SQLAlchemy core. Are there any questions? Yeah?
So, who is SQLAlchemy really for? I'm thinking, is it for the beginner Pythonist, or is it more for the software developer Pythonist, or where in the spectrum are we, especially on the ORM side, understanding?
Yeah, so I mean, SQLAlchemy, I would say, is for the Pythonista in general. I would say anywhere that you are today writing text SQL, and show of hands, how many here are writing text SQL? Yeah, you should probably be using SQLAlchemy instead. It gives you all the power of Python and doesn't let you make the same mistakes that you can do in text or SQL. So that's sort of the target audience. And then, like in Python in general, right, you can start very easy, and then you can build up all the layers of complexity. And we're going to talk about some of those layers of complexity today. Yep.
Do you have some suggestions for driving the adoption of SQLAlchemy, right? Because the new colleagues I get out of university, right, they don't understand. They want to write SQL in text. They don't understand why they should use an ORM.
You can tell them to take this class afterwards.
Yeah, but then it's like an extra complexity.
Yeah.
They have to learn so many things.
Yeah.
So how do you like prioritize and drive adoption?
Yeah. But I think we can take that at the end if that's okay. Yeah. Any questions on the SQLAlchemy part before we move on? Excellent. I get very enthusiastic when I talk about stuff, so I speak quickly and fast. So if I ever do need to slow down, just raise your hand, and then I will try to accommodate. So core SQL. So then, as I mentioned, it's built on layers. So SQLAlchemy itself is, of course, built on DBAPI. The ORM, which we'll look on later, is actually built on top of core. So that's why it's always important to understand your building blocks. And this is probably what I would show people who are used to writing textual SQL, because it maps very easily to those constructs, but with extra benefits. So the first thing we have to do is to have some data. So I have cleaned up some data from OpenData DK, which has some data about parking, available parking in various areas. So the details aren't that interesting, but we also have some sample data to work with. So as before, the first thing we need to do is actually create some tables. So this is more of a closer to real life example that you might do at work or for fun, if you're like me. So of course, we import SQLAlchemy, we create our metadata database, and then we have to create our tables, just like before. So now we can get a bit more interesting with the types, because SQLAlchemy has a rich database type system, and then knows how to convert those rich types back into Python types later. So we have some IDs, some foreign keys, some varchars, integers. So notice that we can also set up these foreign key relationships. We can tell SQLAlchemy these are primary keys. We can add uniqueness identifiers, all those fun things that you're used to from SQL. But I'm driving it all from Python. So if I run this, nothing is actually going to happen. Everything we've done here is sort of in memory on Python side. We haven't talked to any databases at all. SQLAlchemy does support what's called reflection. So if you have an existing database and you're too lazy to type out this, you can do something that's called a reflection, where you pass it the engine, and then it'll look up all these types and sort of give you these tables back. In general, I recommend writing it out, because you don't have to write every single column. This is just the columns that you need Python to be aware of, again, because it's all happening on this side, not on the database side. But it gives you an explicit schema, and it also allows you to do things like migrations and easier introspection of what is it actually you have available, right? So in general, this is what you're going to be doing. So we have our facts, which is the parking table with the count per hour, per year month, per area. We have a dim area, which says something about the area, where is it in the city, street name, that sort of thing. And then we have some different parking types, kind of like in enum. So given that we are starting a new database, because we are going to be running our own, for those of you who have Docker installed, you can uncomment this and then run it. I'm going to be demoing this with Postgres, because it's gives you more of a proper database feel. If you do not have Docker installed and you want to follow along, you can uncomment this bottom one. Then you'll be running with SQLite, which is that file database that we saw previously, and that's all built into Python. But as mentioned, I'll be running in actually, let me open my database editor first. Who of you know that PyCharm has a full SQL integration? Yeah, it's awesome. One of the best reasons to get a pro license. I actually paid for it myself. So we set up our connection string. The connection string will vary depending on what database you have. Again, for you Oracle people, I'm very sorry. We use Oracle at work as well. SQLAlchemy will use that connection string to infer what database APIs it needs to, drivers needs to load and all these things. So of course you need to still have your database driver application installed, in the sense that you need for Postgres, something like CyclePG2, for Oracle, CX Oracle, and PyODBC. You still need to have those installed. But SQLAlchemy will know which one to use based on the prefix, in this case, PostgreSQL. So if we look at our meta, you can actually see it's this type called facade dictionary. So I can actually look up a given table in here. Oh, if I could type. Oh, it helps if I pass it the right area. So I can actually grab the tables that I defined out of the metadata, and that's actually what's happening behind the scenes in SQLAlchemy. And it's the same thing if you do the reflection. It'll populate the metadata tables, and you can grab them out of there. But to actually interact with the database, again, we need to create a connection, make sure we set future equals true. And now we can use the metadata object to create all. And if I open up my database editor over here, probably should have done that before you came, huh? Let's see, I believe it was just Postgres. Postgres. Let it connect, and we should see that we now have in the public schema, we have 3 tables, dim array, dim parking types, and fact parking. So it created all those for me with the appropriate, you can see the keys here. We have some foreign keys mapped, like all that SQLAlchemy just took care of it for me, which is very nice. Of course, it has a drop all counterpart, which will drop all the tables that it knows about. So again, drop all is not going to drop all the tables in the database, only the ones defined in the metadata. So if we want to insert something, we can create a SQL statement. So I'm sure you've all written an insert into statement before. The SQLAlchemy version maps pretty closely to most of the SQL constructs. So sa.insert into the table, dim parking types, dot values, the values I want to insert. And that converts nicely into what you would expect. And again, I cannot do SQL injection. SQLAlchemy does not let me do SQL injection. So that's a nice added benefit if you're trying to sell it to your colleagues. It'll automatically create these parameters and do parameters queries. You can also do all the tables have some helper methods to generate this SQL for you. So for example, the insert, we can just do it straight on the dim parking types.insert, and that'll generate the exact same SQL. So again, to actually execute, we need to open a connection in a with block. General rule, always use a with block unless you have very good reason not to. I might break that rule in this demo because it looks a bit prettier if I'm not having with blocks all the time. But always use a with block. That'll make sure you don't have lingering connections, and your DBAs will be very, very happy with you. So now I just executed that SQL. So if I go back to the database, we would expect something, right? Wrong. SQLAlchemy doesn't presume that you want to actually commit the data. That's because SQLAlchemy works is something called unit of work, which we'll cover in a bit. But if I actually want to say, yep, I'm sure, now I'm ready, then you have to call commit. Everything is inside of a transaction. So if I go back now and refresh, now I have the data in there. We can delete some rows. Again, I have this helper method on the table, .delete, and I can chain on a where clause, and that'll give me a classic delete from. Again, parameterized, again, no SQL injection. I execute that, make sure I commit, and then we can go back and see it's gone, as you would expect. So this is what we call commit as you go. You have to tell SQLAlchemy that now is the time to commit. So if you do, you can also call a rollback. So you can control the data, the flow of data. So if you're, for whatever reason you're not happy, then you can roll back at any points. And that'll basically undo everything up until the last commit. So if I do the insert and then commit that and then delete it, but roll back, would I have data in my database or would I have no data in my database?
You wouldn't
I would have data. So we check. And I do have data. So of course, I inserted, I committed. So that part is sort of sent to the database and persisted. New transaction, I run some more SQL. I'm not happy with that. I roll back. Everything gets thrown out up until the last commit. That gives you a lot of safety when you're working with SQLAlchemy. Like you're not accidentally going to delete something unless you sort of explicitly say it, tell it to commit.
A small nitpick though, like you could omit afterwards as well, right? Because currently you are rolling back the execution, so this execution wouldn't take place anyways, because you are not committing the last.
So I committed in the middle there, so that part gets committed in the
So
center.
the first part gets committed, but even if you were just to do the connection execute delete SQL, it wouldn't.
Oh, you mean the selection or the?
No, this last example, the 15.
Oh, this one?
Yeah. So if you were to remove the connection rollback, it wouldn't.
Yes, exactly, yeah. Because you don't commit, so it doesn't actually happen. So the rollback is more of a, I've done all these things, make sure you throw them away. It's an explicit way of saying, don't keep it anymore. Because remember, this data is still in, it's been sent to the database. It just hasn't been committed. So I might have some more things that I want to do in this block afterwards that I do want to commit. So it gives you that, it can give you a fairly fine level of control. Yeah, over there.
Could you just give an example of when you use the rollback? Would it be like a try, catch, and error?
So actually, the try catch is interesting. We'll get back to that in a bit. But it would be that you, for example, try optimistically to do something and you have something else to do afterwards. It's not something that you really normally do because we have some other methods which are sort of safer by default. But if you're doing something more intricate, where you have multiple things talking to the database at the same time within the same transaction, like you have multiple functions that are sending data to the database, you generally want to have one connection being passed to all these functions. And inside one function, maybe you figure out that, oh no, actually something happened in another function that means I shouldn't do this after all. Then you can roll back that bit and everything else sort of carry on as if it never happened. So yeah, so the rollback part in general, you're not going to use it 80% of the time, but it is happening behind the scenes and a lot of things are going on to look at right now. So it's very useful to know about. So that comes back to this idea of unit of work. So a lot of other frameworks, especially in Ruby, like Active Record, they work on sort of, I want to modify this row, and then I want to modify this row, and then I want to modify this row. SQLAlchemy says, well, instead of doing that, I'm going to get all the things that you want to do, and then then when you're ready, then I'll send it all to the database, and because then I can sort of optimize things a bit behind the scenes in terms of how the queries get sent and what data gets sent and how we flush. So with SQLAlchemy, instead, you want to run all your SQLs and then commit when you're done. So for example, if you're writing a web API, you probably want to open your connection when you get a request, do all your things, then commit, and then it all gets sent to the database in sort of one unit. That's why it's called one unit of work. So everything starts in a transaction. Whenever we open a new connection block, then it actually starts a new transaction in the database. You can also manage that transaction manually if you want to with the begin. So we can again execute this delete, we can commit it, we can start a new transaction, execute, and then roll back the transaction. So do we have data or do we not have data? Do we have data? Hands up. Do we not have data? Hands up. Excellent. I see you're wise to the ways of SQL. So yeah, we don't have data because, again, we explicitly this time manage our transaction and rolled back that transaction. Usually we don't need this level of control. It's very rare that we actually explicitly work with transactions. So SQLAlchemy provides this other form. If you want to explicitly make sure that everything's running inside of a transaction because you have multiple transactions you want to do, or you just want to not have to remember to commit, which is also something that can be quite nice, then you can do this .begin. So .begin will automatically create a transaction for you, run the SQL, and if you do have an exception, then it'll roll back for you. If there is no exception, it'll commit. So if I run my insert and my delete, I should have data. No data. There you go. No data. So committed both at the end. If I have an exception here, I insert, raise an exception, something bad happened. Data, no data, no data. So that gives you a nice safety net. If you use this .begin pattern, it'll automatically roll back if you have a transaction. So of course, you can always implement your own try-catch exception if you want, and then you can get more fine-grained. So SQLAlchemy does provide you these levels of abstraction depending on where you want to be. So what if we have lots of rows that we want to insert, right? Now we've been playing with these toy examples. Included in the repo, there is the CSV of the actual data that we're talking about. Because again, we just created some tables. We haven't actually put any data into these databases. So we just have traditional insert statement query stuff. Grab each of these CSVs in a tuple together with the table we want to insert into. We open a .begin. Because again, this is an example of where we have multiple things happening, right? And we want to roll everything back if one of them fails. So then we iterate over the tuple, get the data file and the table, open it, grab the data as a list of dictionaries, create the SQL, in this case just insert, and then we can use this other syntax that we haven't seen before. So we can do an execute, pass a SQL, and then pass the parameters explicitly. So when you pass a list of dictionaries with keys matching the table columns, SQLAlchemy knows, okay, now I need to do an execute many. So in the DBAPI spec, there's a difference between an execute, which does sort of one thing, and execute many, which is optimized for multiple typical inserts or deletes. So SQLAlchemy will take care of you as long as you pass it a list of dictionaries, and then you get a bunch of speedups, again, depending on your DB driver. So if we look into our database now, we should have a bunch of data. And the facts. So I'm not getting a count up here. That's okay. Yeah, there's a couple thousand rows in there. Just have something to play around with. So this is very typical insertion logic in Python. So replace CSV file here with Parquet or some other SQL or a data frame or something like that. So now we're ready to actually write some logic. That's the fun part, right? Unless you're a DBA or a data engineer, you might not be doing a lot of insertion. You might be doing more selects. So I've lined up a couple of tasks that I want to get done. So you're going to learn a bit about Danish geography, so that's fun. And Danish pronunciation, which is even more fun. I'm not Danish, I just happen to speak it. So task 1, get only counts for gililai. Lovely Danish pronunciation. So what we can do is we can do a select, and we refer to the columns with the table.c.tablename. So we want the count, we want the hour, and then we want everything from the area table. So that's sort of like a select star if we don't pass anything. We do a join to the area, and then we pass a where. So you can see it has this fluent chaining syntax, which you might be familiar with from, for example, working in Pandas, which makes it really nice to modify the SQL. So if we print it, you can see it looks pretty much as you would expect. Select a number of columns from some tables, join with another table. Did you notice that SQLAlchemy actually figured out the join key for you? That is actually one of the really nice things. So because we specified a foreign key relationship, you do not have to worry about it. You just join it, and SQLAlchemy will figure it out. It'll tell you if it can't figure it out, if, for example, you have multiple foreign keys, or if there is some other reason why it can't figure it out. Most of the cases, it'll just figure it out. So now we can actually execute it. We can get all of them, and we get back this row object. That's a list of these rows. So I can do traditional row slicing. I'll get the top 5, and then print the dictionaries. And you can see, okay, that looks reasonable. It's probably not how you normally want to work with data if you're at PyData. So of course, you can throw it straight into a data frame. So that'll get you a nice data frame, because of course data frame supports lists of dictionaries, and the results object can be coerced into a dictionary. So the row object can easily be coerced into a dictionary. And of course, Pandas knows all about SQLAlchemy. It actually uses it under the hood every time you do anything .toSQL or read SQL. So you can pass the SQL and the connection straight to read SQL, and Pandas will know what to do with it. one caveat, when we're working with 2.0, Pandas doesn't quite compatible with 2.0 yet. They need to do like a big rewrite of the SQL internals in general. So you do need to open a connection like this and then pass it to the read SQL function. It doesn't know how to do that itself quite yet. So let's get a bit more complicated. Let's actually have some mathematics. So I want to know the sum of counts, like how many parking spots were available per hour per city. So normally you write in SQL, you do write something and then do a group by. It works pretty much the same way. So SQLAlchemy has this magic object called a func. And this func, any attribute call to it will map to the corresponding SQL function. So SQLAlchemy doesn't actually know about all the functions that are defined in SQL Server or whatever database you're working in. It knows some of them, so it does do some conversion, but basically just takes whatever you put after that func and says, okay, that's the function, I'll just pass it with those parameters. So in this case, SA.func.sum of this count column, I have to give it a label, otherwise it's going to be anonymous. And then I have to include my grouping columns, I have my join, and then I do a group by. And again, I just pass in the columns that I want to group by. So I want you to take away that writing these SQL core statements is very, very similar to writing regular SQL. You should be able to fairly easily take medium complexity SQLs and map them one-to-one in SQLAlchemy core to get started. So if we run that, just to verify, that looks right. And then we execute it, get the data frame, and we can see we have city, hour pairs, and a total count. So this SQL, I mean, it's not bad, but it looks like SQL. And again, we're not writing SQL, we're writing Python. So you're asking how we can convince our fellow colleagues that SQLAlchemy is a good idea. You can actually refactor your SQL. How many people can say that about their text strings, right? So I can split out the different parts and give them variable names. So I can, for example, pre-join the tables, call it a table. I can create this metric, total count, which is these SA.func.sum. And then finally, I have some dry, right? I'm repeating the group by columns in both the select and the group by. That's a common pain in all SQL, right? So I can actually create a list of those columns. And now I can turn my SQL statement into total count, dimension calls, select from table, group by, dimension calls. So now my SQL statement is quite terse, but at the same time, fairly readable. Because especially if you're working with aggregations in SQL, they get very long until you figure out what's actually going on at the end when you read the label. So if we run this, we get the same, just for comparison, this is what it looked like before. Let's actually print this as well, that'll help. So that you can tell I'm not lying. Creates the same SQL. So as an aside, this fluent style of chaining makes it really, really easy to modify the SQL in place. So what you can do is that you can, on the fly, update the SQL, because every statement is just creating a new statement. So I can add a new group by column. I can add a new select column. So there was the group by down here, 3, and up here. And I'm not changing the original SQL. That's the important part. So part of the power of this is that you can write reusable functions and logic that takes in a SQL statement, modifies it, returns it, and then all of a sudden you can have the holy grail. Metrics functions, group by functions, that long SQL query that you have to calculate some random business objects, put that into a function. You don't have to look at it anymore. You can just say, here's the SQL, add this crazy long function to it. So that was an aside, but it is part of the power that we get out of using SQLAlchemy. So again, we can execute it. Notice I'm dynamically adding a limit statement here. So again, I'm just modifying the SQL to add a limit, which gets translated into the backend SQL. And now I have the top 10. So now let's get even more complicated. Let's calculate some occupancy rates. So occupancy rates, in this case, we're defining it as available parking spots and used parking spots at a given time. Just to check, how many of you know what a CTE is, common table expression? What about nested subqueries? Okay. So basically, I'm going to be using a CTE. A CTE is basically a way of creating an intermediate table. So you can have a select statement, and you can kind of name it, and then you can treat that select statement as if it was a table. So that's basically what it is. It looks pretty confusing the first time you use it, but they're super, super handy when you're writing SQL in general. So in order to do this calculation, right, I need to match up, because my fact table, if we looked at it, jump over here. So I have the count type, and the count type is legal or counted. So I actually have in my fact, I have two tables sort of appended on top of each other. I have all the parking spots there are, followed by all the parking spots that are counted. So I need to sort of break these two apart and put them next to each other so that I can do that division across the two. In Pandas, right, it would be fairly simple because you can just do the two selects and then divide across them. In SQL, it gets a bit more funky. But with the power of SQLAlchemy, we can hopefully simplify this expression so that we can break it down into small parts and then just run a small SQL statement at the end. So one thing we can do is we have the space select statements, which is basically going to be our fact table together with our parking types. That'll give us the counts and whether or not it is occupied or legal. And I'm going to be reusing those, so I can write it once and I can just refer to it. So available spaces would be a CTE where we select parking types equals legal. So now I have the available spaces table. The counted spaces is the same, except now I'm doing it with counted, equal to counted. My metric of interest is I have to cast two floats because we're getting a percentage. Multiply by 100, available spaces, counted spaces divided by available spaces and label. So again, like that's already getting pretty long because we have to handle all this conversion stuff, right? So it's pretty nice to get that out of the way and give it a nice label. So I can just say, refer to it as occupancy rate. And the join condition, we can no longer automatically infer it because we're creating these temporary tables. There are no foreign keys for it to match, right? So our join statement actually gets a bit long. But again, we can abstract that into a variable because we have to do it by area ID and join on month and join on the hour because those are the things we want to calculate by. And then I can create the join. So I can do available spaces, join the counted spaces, so now I'm mapping them together, and the join condition is already defined. And now I can actually write my SQL. So now I can actually read it and say, okay, I want the occupancy rates, the city, the year, month, and the hour. Okay, that makes sense in my head. That's what I'm trying to get. If I print out the SQL, that's a lot longer. I don't know about you, but I prefer my version, but I am biased. So if we run this, and notice I can even pass in the inline stuff like order by. So again, SQLAlchemy gives us a bunch of helper methods. So I want order by descending. The occupancy rate is a column. So that has a desk method on it, which will convert the order by into a order by descending. And then I get the occupancy rate, city, year, month, and hour. So if you are in Scannable, then sucks to be you. If you're in Sabi, then you have lots of parking available. That makes a lot more sense if you're Danish. So I hope that you got the notion that SQLAlchemy Core is SQL, just in Python. So how are we on time? 9:47. Thank you very much. So I have a quick exercise here for you. I'm going to give you 5 minutes to give it a go. So basically, I want you to find all the rows where the occupancy rate is above 100. make sure you've executed all the cells before you attempt this exercise. So, yeah.
So I saw that you just select, so you can load from, obviously the SQLAlchemy like set of chain statements that will generate the SQL query. Is it possible to do the reverse? Like let's say I have a task where I have some pre-existing long, SQL statements that I then need to translate over to using SQLAlchemy. Is there some way that I can just dump those long queries and it'll spit out the equivalent? Is that a one-to-one relationship between the simple queries and?
I mean, that would be nice. If you want to start a new open source project, then that sounds like a great idea. No, so there is like the get out of jail free card, which is the text construct. So there is a thing called sa.text. You pass it SQL, and then it'll treat it as if it was already compiled by SQLAlchemy. So it would be the same as if you were to define the whole SQL in SQLAlchemy style, and then sort of have run it. But it's not going to decompose it into the various objects. I haven't tried if you were able to do, for example, the replace select things. That I actually do not know. But you can actually try for yourself. See if you can do the, what did I do? Add a new group by column and or add a new select column. So SQLAlchemy is quite deep when you get into it, so there are lots of handy little tricks like that. So if you do try it, let me know. I'll be curious. Give it 2 more minutes. All right, how are we looking? Do we need a bit more time? So how many of you, this was the first time you ever wrote any SQLAlchemy? All right, cool. Congratulations. So I think we'll call it there. How many managed to solve the exercise?
Was it 780 rows?
I don't have the count. It was more if it worked. You should be able to look at the data and see that you don't have any more than, or they're all above 100. But the idea is that you can chain off of the previous SQL that we have. That's the, you always have to have a trick, right, with these questions. So if I have the SQL, that's just a table. Dot occupancy rates. Actually, let's, I was just talking about how much nicer it is to have name variables. No, I have to remember how to do this too, right? C dot occupancy. Yeah, so there is some new things going on that are deprecated. That's why you always have to be a bit careful. But that's why we have that future thing, because sometimes things will work, and then tomorrow they're not going to work, because then SQLAlchemy 2.0 comes out. So here they're saying that they want me to do a CT. That's fine. Did I misspell something? Yeah, I did. Dot C, dot occupancy rate. There. Always a good thing to do, double check. So now I can do T dot C dot occupancy rate dot where T dot C dot. So there are lots of ways you could have done this. There are many ways to roam in SQL, and therefore many ways to roam in SQLAlchemy. Yeah, naming things is hard, guys. With engine.connect, R is equal to con.execute tsql dot all. Data type mismatch, great. It helps if I actually have a where clause. And then if I throw this into data frame, that looks right to me. So I hope at least you got a good effort. But as with many of these questions, it's a trick, right? Knowing that you can chain these methods onto the previous SQL. And SQLAlchemy does have pretty good error messages. So you can see that when I did the old-fashioned way, it actually warned me that, hey, you should be doing this with a CTE. When I misspelled the column name, it actually told me that like this column doesn't actually exist. So cool. Are you guys ready for ORMs, or do we have any questions on core? Mind blown?
Just give it a few seconds.
Sure thing. Feel free to give it better names. Oh, sorry.
Will SQLAlchemy ever try to optimize the query?
So the question was, will SQL optimize your query? No, it'll not change your SQL query, like the text of it. What it will do is it'll try to optimize the way it sends it to the database. But SQLAlchemy does not presume to know your intent when it comes to the SQL. When we're talking about core. When we talk about ORM, it's a bit more fuzzy, but yeah. That's also part of this leaky abstraction thing we were talking about, that if we try to hide like the SQL code from the Python code, then it starts doing things that you don't expect. And that's part of the design principles of SQLAlchemy, is that it doesn't try to hide anything. It's not trying to be a SQL writer. It's trying to be a SQL parsing engine, let's call that. Cool. Anyone else? Then let's dive into the wonderful world of ORMs. So the ORM is actually where a lot of people get their starts in SQLAlchemy. They're usually coming from something like Django. They're used to working in the ORM there. Maybe now they're trying out some API language like Flask or Fast API. And they're like, where's my ORM? And then they find out that, oh, SQLAlchemy has an ORM, great. In my opinion, that's the wrong way to learn SQLAlchemy because, again, the ORM does magic. That's kind of what ORMs do. They are mapping a Python class to a SQL row. That's what an object relational mapper does. That means that by its very nature, there is magic going on to sort of convert between those two things, which sounds the same thing, but usually aren't. So learning core first lets you always have that escape hatch of, okay, now I'm doing something. I can just drop down into core and write it so it does it the way that I need it to do it. And is one of actually the core, pardon the pun, features of SQLAlchemy, that you can always switch in between because ORM is just building on top of core. So when would you use it? So my rule of thumb is ORMs are great if you're talking about single rows. So that's why it's very common in something like Django or in an API. You're doing request response. Get me this customer, get me this purchase, get me this blog post. Then it works great. If you're only working with one row at a time and manipulating that, or a handful, let's say, then ORMs are great. If you're working with analytics in any way, you want to do counts, sums, aggregations of any kind, core will probably be better for your use case. Because there's also one caveat. If you were to select 100,000 rows and then convert them into Python objects, that's not fast. Converting them into SQLAlchemy rows is a lot faster. So just keep that in mind, that you want to think about tens and not thousands when you're talking about ORM. So again, the first thing we always need to do is to define our tables. That's how SQLAlchemy knows what it's got to work with. So the way we do that is actually fairly different because now we're talking about classes. So the classic way, and I'll show you this because every single SQLAlchemy tutorial you see out there is going to be using this way until everyone migrates to new 2.0 style, is to run this function, which returns a class. And then you will subclass this derived class, and then write your own class on top of that. So remember, this library was written way before we had type checkers, before we had linters. This does not make MyPy happy. It does not make a lot of linting libraries happy. In fact, some of them have coded in special exceptions for SQLAlchemy, again, because SQLAlchemy is so pervasive. But in general, we don't want to return a class, or not even an instance of a class, a type of a class from a function, right? That looks odd. But that's how it was done. So you can still do that. That's not going away. So you create your base class here, and then you subclass it. You always have to give it a table name, and that's going to be what the name of the table in the database is going to be. So the rule of thumb here is in your database, you probably want plurals. You want customers. In ORM, usually you have one customer at a time, so there you want singular, right? One customer, right? And the other rule is that a ORM class has to define a primary key. You're not allowed to have a ORM object that does not have a primary key, because that's how SQLAlchemy keeps track of the individual objects in its own internal representation. So if you can't fulfill those two things, then ORMs are not for you. But that's basically how you do it. And when you do that, behind the scenes, there is, again, this metadata object being created. It's inside of this base class, and this table gets registered. But in 2.0, one of the nice new features is this, that they revamped this registry system. So now we can create a registry instead. And then this registry can be used to decorate your class with .mapped. And that sort of fits in more with how we think about these things these days, right? We have data classes, we have adders classes that use this pattern. Having a class decorator is not a crazy thing to do, right? also fits more in with a registry pattern in general. But the same rules still apply. You still need a table name. You still need your primary key. And in this case, we just have a random address. But it's just a class. So I can add a nice wrapper to it that shows me sort of the key data. And then that'll be printed out. The other nice thing that it does, I remember I told you that ORM is just building on top of Core. It just auto-creates the SQLAlchemy Core table in this under table attribute. So it's right there. You can go grab it and work with it and do whatever you need to do. Notice that we're not defining an init. So this is actually something that's, because again, this predates data classes and adders and all these things. This is one of the first libraries that I had this, I'll create an init for you based on class variables. So scikit-learn will automatically create an init that accepts these. But you're free to define your own init if you want to either restrict what you want to accept, or if you want to do some post-processing of the input arguments before you create your instance. That's perfectly fine. Let's finish up our data models. So we have our address. Let's have a purchase. I have this table args here. ORMs don't really work well in notebooks. They're not meant for that. So SQLAlchemy will complain that I'm going to be redefining these classes throughout the notebook because it messes with this internal registry. So I have this extend existing just means that it's okay. I know what I'm doing. I'm opting out of this checking behavior. It'll still complain with a warning, so don't worry about that. But just to let you know. So just ignore this line. This is for notebook purposes only. But yeah, so the definition is pretty much exactly the same. I have a foreign key. I use these columns. I have, for example, a decimal. The nice thing is I can add these type hints. Again, we're writing modern Python. I can add type hints to my attributes here. SQLAlchemy doesn't care about them yet. There's actually a feature that's coming up that you can do type hinting to, instead of writing these sa.column things, but it's not a feature yet. So right now it's just for my own sake. It helps when we write our code. We can also use more exotic types, like we can use an enum. So for the customer, these customers have a status. They can be gold, silver, bronze. So then we can set the status to be of type enum. And then we get to the cool part about ORMs, which is relationships, which is, to me, the killer feature. So notice here that I define two relationships. Address, so a customer has an address, and purchases. A customer has many purchases. So what does that actually mean? So I still have my database up and running. If you don't, then you have to recreate it. So we have a new keyword here. And again, ORMs are magical. They will create and run SQL on your behalf that you have no control over, per se. So when you're getting used to working with the ORM, you can turn on this echo equals true. Then SQLAlchemy will print out every SQL statement it is writing and running. So that gives you that extra level of control when you're developing that, okay, it is actually doing what I think it's doing. Because especially with ORMs, they're going to be doing a lot more calls than you think they're doing. And then I do the same thing. Notice that on the mapper registry, that's where my metadata lives now. So I can just access it through there. And here's our first example of all the stuff that SQLAlchemy actually does for me. Some highlights is that it actually checks, do these tables actually exist already? If not, skip them in a cross-database agnostic way. And then actually runs all the creates and creates all the primary keys and foreign keys and all those references, as we saw before. And now I'm ready to actually create some data. So you just create an instance. It's just an instance of a class. I have John and Jane here. They're not, I haven't talked to the database yet. They're just a class with attributes, .name, and .status. Everything you would expect from a Python class. Nothing up my sleeves. So the way you talk to your database in ORM is with a thing called session. You're no longer working with a direct connection object. You're working with a session, because the session adds some extra abstractions on top, like keeping track of what is already loaded into memory, what is not, loading primary keys into memory so it can access various data. So we need this session thing instead. But the pattern looks very similar in the sense that we create an instance of session, give it the engine in a with block, and we're just going to call session.execute instead of con.execute. So pretty close, but not quite. So in the session, we add these objects, and then SQLAlchemy make sure that now it knows to keep track of them. Again, I still have to actively commit. It's still an opt-in commit. So if I commit that, you can see we get the inserts, and notice, speaking of optimizing SQL queries, from this, I get one insert that is parameterized. I'm not getting two insert statements. And that's that unit of work in action. Because the session knows, oh, I have two of these things that aren't committed, then I can optimize what I'm sending to the database and write the SQL in a way that optimizes for that insert. So instead of sending 100, it will send one insert with many parameters. So now we can add an address. And we can do that in many ways, but one way is to just assign it to the attributes. So now John has an address. So now if I re-add John and commit that, SQLAlchemy will notice, hey, John now has an address. He didn't have one before, and doesn't exist. So let's insert into addresses this new address. And then we select again to refresh the session. Because we have to make sure that John himself hasn't changed. And then we update him to insert the address ID of the newly created address. So if we jump into the database and look at what actually happened. So this is the magic part of the ORMs, right? Having to keep track of relationships across tables is a pain. So I have my address, and then I have John with address ID of 1. That's pretty cool. And notice that Jane here, she doesn't have an address yet, so she's just null. So John goes shopping, and he buys a magic potion. So when I create purchase, because I set this relationship up, if I go to purchase, notice I didn't set one on purchase. But yeah, the only thing about these SQL queries is they get pretty long when you're doing the echo. We were down here somewhere. But this still works. So why do you think that works? That's a bit odd. Well, if we look at our customer here, you notice I set a relationship to the address table, backref equals customer. So backref is back reference. That means that what SQLAlchemy also does is it registers on the address class that, hey, you have a relationship to customer. You didn't know about it until now, but now you do. Which means that it adds that attribute to the address class or to the purchaser class and naming customer. So you can do it manually. You can explicitly set a relationship on each side and then do back populates, which will say like there is a matching relationship here. Or you can set the backref here, and then it'll just add that attribute for you. So that's more up to your own coding style, explicit versus implicit, and all those fun things. But now, if I add the potion, we see the same thing. We select the customer. So we got a fresh copy of the customer. We insert it into the purchases that this is going on. And then we insert it with the user ID. But again, that's the caveat, right? It's doing some magic for me, but I wouldn't be able to guess how many SQL statements that simple operation would have done if I wasn't quite very familiar with SQLAlchemy. So in this case, it did 2. It could have done lots more if there was more data. So caveat emptor, always make sure that you know what your ORM is doing. We can also just create a purchase. So we have our magic hat here. Then I can, again, connect John to the session. Because if John's not in the session, then SQLAlchemy doesn't know how to look him up to make sure we get the right data. And it'll just complain and tell you, hey, I'm not in the session, so please add me. So when I have John, then I can append him to my purchases attributes. And then, because SQLAlchemy just represents these relationships as a list, I can re-add, and then I can commit. And again, we're generating a bunch of SQL statements, 3 in this case. But it also does some caching, which is nice to know. That's a new feature in 2.0. It does more aggressive caching of your queries. So the compilation of these SQL statements gets cached by SQLAlchemy. And that's what it's telling you here, that it's already seen the SQL, so it doesn't actually need to recompile it. So now, if I go back into my purchases, I have 2 purchases, and they are both are mapped to the correct user ID. So this was my mind-blown moment when I started working with SQLAlchemy, because doing this by hand sucks. That is like the worst part of writing SQL for some kind of API, is keeping track of all these related objects and making sure that they're in sync at all times. So if it takes a few more SQL calls to make that happen by magic, then I'm perfectly comfortable with that. So we have some data, and how do you actually now get that data back? So the big thing that happened in 2.0 was a realignment. If you're looking at pre-2.0, then you would have different syntaxes for selecting, depending on whether it was ORM or whether it was core, which meant that every time you Googled, how do I do this SQL in SQLAlchemy, you always had to make sure that you're either looking at the ORM version or the core version, which was really annoying. In 2.0, it's been aligned. Now we're using the same SA.select, whether or not it's in ORM or whether or not it's in core. And that's fantastic. Only one API to learn, right? So in the end, you just say SA.select customer. It's the same thing as if it was a table in core. Filter by is just a nice syntax. Instead of saying .where customer .name equals Jane, you can do filter by keyword argument value, and it just does the same. So it's a convenience method. And it creates the correct SQL. So, and again, the execution is almost the same. We're just using a session instead of the connection, but we do session that executes, one or none, and we get our Jane back. So especially one or none is something you're going to be using a lot more if you're using the ORM, because then you're typically in a context where either the customer exists or he does not. So you're fine either way, but you just need to know. But if there are 2 customers with the same value, then you probably did something wrong. So that's a nice level of safety you get there. So, and we have our customer Jane. But wait, that looks a bit odd. What happened here? So again, things changed a bit in 2.0. If this was 1.4, it would not look like this. You get your Jane back and everyone would be happy. But now we're aligning our syntax across core and ORM. And in core, when you do select, you get back a row object and you have to access each value in it. Exact same thing for ORM. So if I do Jane 0, then I get Jane back out. I actually don't remember if it's a named customer. Yeah. So basically we get back a result, a row that has one column in it, and that column is called customer, and it has Jane inside. So obviously that's a bit clunky. So we introduced this thing called scalars. So scalar was actually a thing back in the day as well, but it wasn't necessary for ORM. Now it is. So scalar just says, I want to, whatever is in the first row in the first column, that's the value I want. And if you're using multiple, then it's just whatever's in the first column, that's the value that I want. So you tack on scalars to your executes, do one or none. And now we get back what we would expect. So because this is such a common pattern in 2.0, we have a bunch of these helpers which do it in a single method call instead. So you see scalar, one or none, scalar, all scalar versions of all the various operations. But just know that it just means adding the scalars modifier to the previous results access. So one more way, because obviously in Python we like to have multiple ways. If you know the customer or the primary key, then you can use a sort of a shortcut syntax which lets the session optimize the query. Because it checks, do I have this already? Can I reuse something, or do I have to go fetch it? So if you do session.get on the table and pass the primary key, then it'll do this optimization to get out the customer. And we get the same customer back. So now that we have our customers, we can start asking questions about the related attributes. We set up these relationships. We probably did it because we care about them. So let's put John back into the session, and then let's ask about his purchases and his address. So we got a bunch of SQL being generated, but all I did was just access an attribute. So what's up with that? And if I do this with a regular attribute, there's no SQL being emitted at all. So this comes back into what relationships actually are and why you have to be a bit careful. You see we have here when selecting the customers, we have selecting purchases, and then we select the addresses. So these three actually created 3 SQL statements, even though you're just doing an attribute lookup. So this idea of relationship loading is pretty important if you want to really take advantage of relationships. So by default, SQLAlchemy ORMs are lazy. If you're fetching a customer, you're only getting the rows from the customer table because joins can be expensive. So SQLAlchemy doesn't want to presume that you automatically want to get the join with all the addresses or purchases. Imagine like if you're at Twitter and you get get all your posts, or it's a massive join, right? So by default, it's lazy because that's the safest. If you don't know what's going on, though, it becomes quite dangerous because then you're doing attribute lookups everywhere, not knowing that you're constantly sending SQL statements to the database, which will be fine when you're in dev. And then you hit production, all of a sudden your scale increases by 10-fold, 100-fold, and your SQL queries increase by 1,000-fold. So to get around this, you can explicitly, in a query, you can explicitly say, I want this to be done in a different way. So when I select customer here, I can pass this options, and I can say that the address relationship should be done with a joined load, and the purchases relationship should be done with a select in load, where customer's name equals to John. So if we look at this now, so if I get the customer here, let's see if we can find that. Then you see I do a left outer join with addresses. So this is this join load. So then in one SQL statement, it's doing a left join with the relationship table and getting all those in, because obviously we want to have all the customers, but we also don't have an address. That's a perfectly legitimate query. The other option is to do a select in. So there we can select the purchases where purchase user ID in primary key. So there you're reducing it to 2 select statements, one to get the customer, and then another one to select all the purchases where the purchase ID is in this customer ID. So again, it comes down to flavors, and it's more up to you sort of exactly how it should be done, because you're the one who knows the database. Again, SQLAlchemy's philosophy is we don't hide away the SQL. You are still in charge of the database. You know best about how the database is structured. We're not going to make all these assumptions for you. We can also set these up from the start. So when I define my relationship, I can also say, how should this by default be done? So I can say lazy equals joined, we'll do the join load, or lazy equals select in, which will do the select in load. So you can predefine that if you know that every time you want that, and then you can opt into other behaviors depending on your query. I'm going to skip over this exercise. So you're free to do this for yourself. I just want to talk about some of the nice things that ORMs give you on top of relationships, which mainly are that ORMs are just classes. And classes are first-class contracts in Python. Gives you a lot of nice features. For example, you can create a mixin. So let's say you want to have 2 columns on every table that says when was this created and when was the last updated. Normally you'd have to do that by hand, but you can just specify a mixin. So if you haven't seen mixin before, it's just a name for a pattern where you're not supposed to override it. It doesn't have behavior. It just adds some extra stuff to your class. And then if I list my columns here, you can see I now have 2 more, created at, and somewhere over here should be there, last updated, and created at gets automatically added to this class. So the other nice thing is that we can define a class method. So this is actually a pretty powerful construct in Python, how you define alternative constructors. Especially if you're doing serialization, you get some JSON, you want to convert it into your class. The easiest way to do that is to create a class method that defines, okay, from dict, I'll take a dict, and then creates the class based on that. So you can control that behavior. So this is that warning I was telling you about, that I'm redefining the class, which you should not be doing for demo purposes only. So now I can create a user object from a dictionary and sort of control that behavior. We also have properties like is admin. I can, of course, manually write the code to check if this user is an admin or not, or I can add a property which makes it look like it's an attribute. So now I can do is admin false. The nice thing is that SQLAlchemy actually lets you hook into this behavior in Python. So we have this thing called a hybrid property. So a hybrid property just means that we tell SQLAlchemy, hey, this thing, you can actually use it in a SQL statement as well. So instead of defining a property, we define a hybrid property. And then we create all that. Oh, and we get a user. We add that user. And now I can do, in my SQL statements, notice I'm using the class, because it's a class property and not an instance property, is admin. And that will compile into where users.role equals role. So now I have a nice class property that I can use both after I get my instance and in my SQL statements. We can also verify those mixin while we're at it. So last updated 9/23/26 and 9/23/50. So those are actually working as intended as well. Sometimes the logic doesn't map as easily. In this case, the property was a simple equals that gets overloaded in SQLAlchemy and gives you a where clause. Often it's not that neat. So let's say, for example, that we have that the role can be one of many. So we're doing an in. That doesn't translate to SQLAlchemy. So we need to specify the SQL that gets run in the SQL world to match the result from the Python world. The way you do that is you specify your hybrid property. This is the Python code. And then you can do another one. It has to be named the same. And then you say the property name dot expression. That tells SQLAlchemy this is where the SQL expression you should use comes from. And it's on the class level, so you get a class. And I can say class.role in. This is the way you say create an in statement in SQLAlchemy, this list. So now I have my user. I have a property that I can access on the instance, or I can use the isValidated. So just notice that because we're using a bit of SQLAlchemy magic, it can't quite show you what's going to happen because it needs to do some extra processing of the query parameters that come in, so which is why you get this funky post-compile role. But it does work, and we get back Jade, who was validated. So that's how you can do that. So we only have 5 minutes left, so I just want quickly to mention hybrid methods. Basically the same as a hybrid property. It just works for methods instead. So let's say we have our purchase here. We want to define the ability to calculate an ROI on our user here, sorry. So basically take the sum of all its purchases and divide it by the total cost, and that'll give us an ROI on this customer. So I need to have some information in order to calculate this, which is why it can't be a property. I need the cost. So I execute, boom, boom. I'm sorry, there's some duplication here. Don't write your demos late at night, people. Here we go. So here we have JNR user with the purchase of 0. I can also have a plain Jane regular method here, purchase, which just adds to the purchase cost. Notice that you can do nice things like this, where you can abstract away some logic. You can pass in the active session and then actually work with the instance directly on the method. So in this case, I update the purchases with the item cost, and then I persist that into the database. And then this ROI method down here. So now we have some purchases. So if we looked at here, notice it's actually selecting from the database the purchases, and then I can actually calculate the ROI. This is on the instance, so it's not doing any SQL. But I can then use it in a where statement, so where ROI is greater than 1, for example. And that translates it into the correct statements. So I can execute that, and then I get back my chain, and then her ROI, just to show that it was working, is greater than 1. And with that, I will close this session. So thank you very much for your time. So we have 3 minutes before at least I get kicked out. You're free to stay. You can ask some questions in here, or otherwise just meet me outside. I'll be here all weekend. So good timing. So, yep, we got a question over there.
So you compare this mapper with things like data classes and things like that, but these ones give some extra functionality like a good wrapper method, things like that. Is there a way to combine two somehow, or not really?
Yeah, actually, that's one of the imperatives for changing the way of registering classes was explicitly to support data class and adders. So you can actually have your data class and then tell SQLAlchemy, this is the class that I want you to use as sort of the serialization class. And then it just works, peanut butter and chocolate. So I would refer to the docs, considering we have 2 minutes. But if you do SQLAlchemy, so the only, it sounds amazing, but it is a bit more verbose because obviously it has to do a bit more work. Oh, that's the one I wanted. See, and I will plug the SQLAlchemy documentation. They are fantastic. They do spend a lot of work on it. So this whole section here is how you can do exactly that. So basically, you have to redefine everything twice because you need the SQLAlchemy representation of the table and your data class representation. So it's not as pretty, but you don't have to do it inline. Like you could have your table's definition somewhere else, and then just set the table equal to it. Because this is the piece of magic that the mapper also does, is to generate this for you. So, oh, we have one all the way in the back over there. Excellent question. So you're asking about the database migration tool for SQLAlchemy? So the same guy who wrote SQLAlchemy also wrote Alembic. So basically, Alembic is able to read all your SQLAlchemy definitions and then automatically create a migration based on that by introspecting the target database, your models, and creating a diff of the two, and then writing the DDL to create the difference between the two. Then also registers, when you apply it, it also registers in the database, hey, version blah, 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 some SHA is the current one, so it can always keep them in sync, knowing what version your database is in. So then you can do like git style, upgrade, downgrade between versions of your database. So check that out. That's the current gold standard for at least for SQLAlchemy.
Cool. Thanks, Anders. It was really good.
Thank you very much.
I really like the hybrid